All right, hi kids. It's Mr. Quammen here. Hopefully, you guys are all listening to this and not on the main screen. That means that all your Chromebooks are working. What I would like you to do right now, you should have this sheet of paper out in front of you, this in-class review lessons 2.4 and 2.5. This is what the quiz is going to be on. It's going to cover this material. Many of you were doing exceptionally well, really, really good on this stuff before I left, so I thought it would be a nice review. What I'd like you to do is first go through all 5 problems. 1, 2, 3, 4, and 5. I want you to go through these, and what I want you to do is I want you to do all the problems yourself. All right, when you finish, all right, I want you to continue this recording. So I want you to pause it right now and then start it up as soon as you get all the answers or get through all 5 problems. All right, so pause it and then start it when you're done. All right, so you have completed the first 5 problems. So what I'm going to do is I'm going to show you the answers. And what I want you to do is I want you to check your answers, all right? I'm going to go fast through this so you can speed it up, you can pause it so you can check your answers compared to this stuff, all right? And then I'll go through and kind of teach you these things if you didn't understand it. So here are the answers. Here's the answers down at the bottom. And again, you may pause, go back to see your answers. Here's number 2. All right. Here are your answers. Again, I would pause, look at this stuff. All right. And then 3. The highlighting, that's my circling. That's your answer. Number 4. There we go. And number 5. All right, so if you got all 5 correct, what I would want you to do right now is I want you to raise your hand, tell the sub that you got all 5 correct, and then you are going to get your review packet. But if you didn't, all right, you can do one of 2 things. You can lie and say that you got them correct, and then you can start working on the review packet. Or you can pause this, all right, go back to the ones you didn't get correct, and go through my little slide, because the rest of what I'm going to talk about is these 5 problems. I'm going to go through them. So try to find in the video when I'm going through and starting these problems so you can see which ones you need help with, all right? If you got all 5 incorrect and wrong and you need to listen to it, well, we might need some more practice. But if you got them all correct and you're good, start working on the review. The sub has it. If not, find your missing problem and follow along with me. All right, here we go. Let's go to problem number 1 and let's do it for ourselves. All right, here we go. Number 1. So it says, you are growing bacteria for a science experiment. You begin the experiment with 7 organisms. So we're starting with 7. This is what we start with, which is why our graph starts at 7 here. Hey, look at that. Now it says, identify the key features. So these key features are right here. These are the key features. Here, 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 all the stuff down here. All right, so let's go through it. Type of the function. Well, this is exponential because it is increasing. It's curved like what we learned on Friday. It's not a straight line, it's curved, so it's exponential. What is the x-intercept? Well, if I look here on the x-axis, there is nothing that touches the x-axis here. There is absolutely nothing. Look at that. The graph doesn't even touch that. So what we write is none. And then for y-intercept, you look at where it touches the y-axis, and here is the y-axis. I'm going to put a line there, and it touches the y-axis at, and it's hard to see, but it's 7. All right, so the y-intercept is 0, 7. You must write it like that in a coordinate, 0, 7. All right, so now what we have to do is we have to say, all right, is it increasing or decreasing now? Is it increasing? Well, if you look, we read this from left to right, and it is increasing. All right, so it's increasing. Now, the second thing says positive, all right? Positive. Well, positive means it's above the x-axis. Where is our graph above that dashed line that I just put on your screen? Well, it's above it for all values of x that are greater than 0, because that's where our graph starts, at x equals 0, right here. So every value of x that's greater than it, boom, we're going to have our line positive on above your x-axis. Now, maximum, minimum. Here we go. This guy, maximum or minimum. Now, you can never have both. You'll have one or the other. In this problem, we have a minimum here. We have a minimum, which is where we started our graph, at 0.7. But for minimum maximum, you just say the y value. Just the y value. So that is 7. All right, so there's no or none for the maximum, but we have a minimum of 7. It's your y value. All right, which is 7. Now, asymptote. Now, this is different. Since this is a real-world problem, there are no asymptotes for real-world problems, so we will put none. If this was just a regular equation like y equals 2 parentheses 3 raised to the x power, then you would have an asymptote. But because it's real world, we're talking about organisms, there is no asymptote here, so we put none. And then lastly, domain. Domain means x values. So what x values are here on this graph? Well, the x values that are shown are x values that are greater than 0. All right? Those are the domain values. It's anything greater than 0. So awesome. Now we're almost done. The last thing we have to do is we have to say, what does the minimum mean in the context? So it kind of gave away, did we have a minimum or maximum? But what does this mean? What does it mean in the context? Well, the minimum is 0.7. All right, it's 7. So what does that mean? Well, what it means is this. You began the experiment with 7 organisms. That's what it means. So you will write down the exact thing that it means. You begin with 7 organisms. That's it. So that's what you write. So that's how you do number 1. So let's go to number 2 now. All right, number 2. Now, number 2, it says describe the end behavior and then when the following graphs are positive. So we are asking 2 things. So let's start with the first one here. We're going to start with A. So end behavior, as x increases, so that means as x goes to the right. So as we're going to the right, what's happening to our graph? So what you're going to look at is this top arrow. Where is it going? Well, it's approaching positive infinity. So you can put infinity or positive infinity. Now, as x decreases, that means going to the left. As it goes downward, going to the left. So we look, as our graph goes this way, we end up down here. And that is negative infinity. All right. Now, lastly, this problem says, where is it positive? It's positive for what values? So positive, what that means, all right, as we did in the last problem, you may or may not have gotten that wrong, but who knows? Positive means it's above the x-axis. Where is it above the x-axis? So what you need to do is you need to find where it touches the x-axis, because everywhere to the right, oh, that's a cool arrow, right? Those are values that it's positive for. So it's positive for x being greater than, oops, it's not allowing me to write that nicely, so I'll get out of pink. So x is greater than, and then at x-intercept, that is 4 right there. So it's x is greater than 4. That's where it's positive. That's where it's going to end up being above the x-axis. If you wanted it negative, it would be everything less than 4, but we want positive. So now, let's go with B now. So B, here we go. So B, it says it increases. So as x increases, that's going to the right. So as our function goes to the right, where is it going? It's going to end up all the way up here at positive infinity. Yay! All right. Now, as x decreases, so I'm going to leave that up here so you know where that came from. And as x decreases, that means goes to the left. So as we go to the left, where is this thing approaching? Well, it's not approaching negative infinity this time. It's actually riding along an asymptote. So we have an asymptote here. And that asymptote, I just covered up the number, is at negative 4. So this guy is going to approach negative 4, the y value of negative 4. So it approaches negative 4. All right? And now lastly, it's positive. So let me kind of erase some of the stuff so it's not kind of confusing you here. All right, so now it's positive. It's positive, positive, positive. So positive, again, just like the last problem, is where it's above the x-axis. So here, it's above the x-axis here, because your x-axis is the one with the arrows. So now we need to see where it touches the x-axis, and that's at 2. So we're going to say, all right, it's positive for x values that are greater than 2. That means values that are to this direction of 2. That's where you're going to get into that highlighted region. So there you go. So that's problem number 2. Cool, cool, cool. Let's go to problem number 3. So now this is what we were learning the past couple days. This is rate of change, also known as slope. So it says use the table below to determine the rate of change for the interval 10, 15. So this This is not a coordinate. Remember, these are x values. These are x values here. So this is one x value, and this is the second x value. So this is our first one, and this is our second one. It's not a coordinate. So now what we can do is we can take these x values and correlate. That means find the y values from this. So now, if we have an x value of 10, so we got 10 here, what's our y value? That's 1200, or 1,200. And if we got an x value of 15, that gives us a y value of 1050. So now, knowing what our coordinates are, now we can find what the question is asking for, the rate of change, also known as slope. All right, so I'm going to write that out, slope. All right, so to find the slope, rate of change, we take our two coordinates. So we got 10, wrote that a little funky. So 10, 1,200, and then 15, 1,500, or 1,050. All right, so now we stack them and we subtract them. Remember, that's how we find our slope. We stack and subtract. So we go 10 minus 5, that's negative 5. And then we're going to go 1,200 minus 1,050, that's positive 150. So now what we're going to do is we're going to simplify this. Now, because this is real world, well, it is real world, even though it doesn't seem like it because we're talking about weeks and amount owed in dollars. We need to simplify this with a denominator of 1. So we want to divide this, and it might become a decimal, but that's fine because it's real world. So we go 150 divided by negative 5, and you're going to get negative 30. And really what this means is negative $30. So now here's the last question. Answer in context. So you want to identify what that 30, this value, what this really means. What does that really mean? So negative 30 over 1, well, that doesn't mean for every 1 week there's a decrease of 150. Look, there's got to be 30 in the answer, and that's only this. See, for every 1 week, there is a decrease of $30 of how much you owe because you're paying people back. Clearly, that's what the problem is about. It didn't say that, but that's what it would mean. So here we go. That's how you do number 3. So let's do number 4. Very similar. Now, number 4, very similar to the last one. So if you need some extra practice, go back there, or you probably end up getting both wrong if you're listening to this. But anyway, use the table to determine the rate of change. Again, rate of change, which means slope. So we're going to stack and subtract. For the interval, again, intervals, these are not coordinates, all right? These are x values. So the interval of 312, and then it says interpret your results. So let's get after it. So here we go. We got our coordinates, 3, and then we got another x value of 12. Remember, it's not a coordinate. Those are just x values. So now we got to correlate. If we have 3 minutes, it is 18. That's your y. And then 12 minutes, your y is 144. So now, just like we did before, we're going to stack and subtract. That's the most important part, subtract. So here we go. We're going to go 3 minus 12 and make sure this stays on the denominator. So it's going to be negative 9. And 18 minus 144. 18 minus 144 is negative 126. So now what we need to do is we need to simplify this. Because this is a real world problem, again, real world, it's talking about minutes and number of bacteria. Minutes, number of bacteria. I need to make sure that my denominator is over 1. Well, first we can simplify. Negative over a negative is positive. And now you just go 126 divided by 9, and you're going to get 14. So this is your simplified rate of change, or slope. So what does that mean, 14 over 1? Well, the rate of change is this. The rate of change is 14, which means for every 1 minute in this problem, for every 1 minute, and that's minute, that's an awful looking minute. Let me erase that so you can see it better. Minute. All right. There are, now look, we're talking about bacteria. There are 14 more bacteria. That means we're growing 14 more bacteria every minute. We're increasing the amount we have every minute. So that's what our rate of change means. It means you're growing it or sometimes decreasing what we have. So that was 4. And lastly, here is number 5. Number 5 now, the function models the fly population. The population starts with 10 flies. So you start with 10. and then doubles, right? Every 2 days. Ooh, look at extra stuff. Now, some of you might be saying, I can write the equation of this. Well, I don't want you to because I actually give you the equation. So the question isn't asking you to write the equation. It's asking you to find the rate of change or slope of this equation. Now, this is tough because this is exponential. So you can't really do it. You need to have an interval. Oh, they give us an interval. Look at that. So the interval is 4, 8. You want to find the rate of change over 4, 8. So after we do that, it says interpret the rate of change. So first we got to find it. So here we go. 4 and 8, those are your x values. Now we need to find our y values. Now, you can do this one of two ways. You can do it algebraically. That's fun sometimes. Or what I'm going to do is I'm going to pull up my calculator, which you can see on my screen, and I'm actually going to type this in to my calculator. Now, I'm going to go y equals, I'm going to clear what I have, and I'm going to type this in. 10 parentheses, 2 parentheses, close it, and then raise, so caret. And now, because it's x over 2, I got to make sure that my exponent is in parentheses, x divided by 2. And close that parentheses up. Now we're ready to go. Now you don't want to see it. You don't need to see it. You can, but you don't need to. What you do want to go to is second graph. And we want to see our table. And we want to see our table at 2 values. We want to see it at 4, because at 4 you have 40. And at 8, so I'm going to keep going down, 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 one more. 8 is 160. So hey, thank you, calculator. I'm done with you now. So now I found my y values. So now I have my 2 coordinates. I want to find my rate of change or slope. So I stack and subtract. So I got 4 minus 8, that's negative 4. And 40 minus 160 is negative 120, or 120. Now, because we're talking about a real life thing, fly populations, that's a real thing, we need to simplify this with a denominator of 1. So we're going to go negative divided by a negative is positive, and 120 divided by 4 is actually a nice number. It's 30. So this is your rate of change. But the question didn't just ask for the rate of change. It wanted you to interpret the rate of change in the context of the problem. Well, let's interpret it. Well, 30 over 1, what that means is well, it's not really we, but we can say we grow. Can't really grow flies, but we're going to grow them now. We grow 30 flies every 1 minute. Some of you are like, why does he say every 1 minute? Well, I just emphasize where the 1 comes from. But really, it's you grow 30 flies, or 30 flies are born every minute. That's what happens with this population. So, we're now done with problem number 5. You have now completed all 5 problems, and you hopefully have a nice little review of what's going on for this quiz. So you can raise your hand now, you can get your review packet, and begin it. All right, make sure that you are working the entire time. All right, I want you to make sure you're taking advantage of this. Mr. Ortiz knows this stuff better than anyone. All right, ask him questions. The sub may know math. Ask her or him questions. All right, if not, keep working. There are some really smart people in the class. Everyone's a very good math student. Ask your group mates. They're smart. All right, ask them how to do this stuff. The quiz is not going to be crazy hard. You've seen this. You see the review. All right, the review is very similar to it. If you have any questions, feel free to come into my classroom tomorrow morning. That's Tuesday morning, all right, at 7 o'clock, and I will help you more than anything. If you cannot get here that early, whenever your bus, car, horse, truck, bike, motorcycle, helicopter, however you get to school, all right, as soon as you get here, you can come in and I will be more than willing to help you out. I will also do a little review right before we take the quiz, okay? Don't sweat it. Don't freak out. You're going to do great, all right? Have a wonderful Monday, and I will see you all on Tuesday. Take care, guys.